Alright, so in this video we're going to be talking about dividing radicals, and when it comes to dividing radicals there's a few things you need to be aware of, and I'll describe them here in this video. But one of the first things that is typical is if you have a radical or a root like this and you have a fraction inside, then the best way to handle it is just to split up the radical with the numerator and the denominator and then simplify separately. So what that means is, using this example here, you have a square root, so you could separately give the root to the top and the bottom. So you have a square root of z to the 9th on the top and a square root of y to the 10th on the bottom, and just do the simplifying top and bottom separately. So if this was the problem you were working on, then you would just ask yourself, okay, this is a root, this is an exponent, I have to divide. So how many times does 2 go into 9? Well, it can go into 9 about 4 times with 1 left over. So z to the 4th power, and then that 1 that's left over is going to be a square root of z to the 1st power that's going to be inside. For the bottom here, it looks like we have y to the 10, so 2 goes into 10 about 5 times, so y to the 5th power comes out of the root. So that's what it means by this first statement here: split the radical for the denominator and numerator, then simplify separately. Also, another thing to be aware of: roots cannot be in the denominator. So this is an old rule of thumb, and there's a reason why we avoid roots in the bottom. It's just because it's just really hard to divide by a root. Roots often give these like hard decimal values to work with. So we just don't like to divide with roots because they are difficult to divide by. So we try to avoid having roots in the denominator. Now, clearly I didn't get a denominator in my root, so that's good. So in this case, I don't have to worry about that. So what I can do is make sure that when I get my answer is to not have a root in the denominator. So you're probably going to ask, what happens if I get a root in the denominator? How do I handle that? Well, that's going to be further down. I'll explain what to do. Also, one of the things you can do is if you want to cancel out a square root. So we're going to get into a situation where we might have a square root in the denominator. This happens often. What you can do is just multiply and cancel out the square root. And this only works for square roots, by the way, if you have the same root. So we mentioned this in the last video, but what you can do is anytime you have a square root, you can multiply by the same square root, and that will allow you to cancel. Just to give you a quick example is, let's say you have a square root of 5 in your way and you want to get rid of it. Well, just multiply it by a square root of 5, and that will help you cancel out the root. And there you have a square root of 25, which gives you 5. So you wouldn't have to do this intermediate step because you know anytime you multiply a square root, they cancel and just bring out the number that's inside. Or you could do this intermediate step and then realize you get to the same answer. So we'll practice some of these concepts down below. So by the way, this was the answer for part A. So moving on to part B here. So same situation, you have a fraction that's inside this square root. And so let's go ahead and split those up, top and bottom. So I have a square root of 5a to the 5th, and I have a square root of b 12th. So on my top here, I don't think there's much I can do. This 5 doesn't break down into anything. Like 5 is not a perfect square root, neither does it break down into anything because it's a prime number. So let's deal with the a here. So this exponent of 5, 2 goes into 5 about 2 times, so a squared comes out, and I have a leftover 5 that's inside that I couldn't take the square root of, and I have a leftover a to the 1st. Since 2 goes into 5 twice, but there's still 1 left over, so that's why a to the 1st power is still inside the root. For the denominator, 2 goes into 12 6 times, so b to the 6th does come out, and we don't have a square root on the bottom or any root in the bottom, so this is my final answer. Okay, let's try a couple of more of the same types. So this one here, you have also another square root. So I'm going to take the square root of the top and the square root of the bottom. So the square root of the top is kind of nice. Square root of 4, you don't have to make a factor tree to know probably it's 2. 2 goes into 6 3 times, so x to the third power comes out of the root. Square root of 9 is 3, so same thing, these are a little bit simpler. And then 2 goes into 4 twice. So y to the second power comes out of the root, and I can't really simplify any further because x and y's don't combine, and 2 and 3 already are reduced. So this is it. This is my final answer. All right, moving on to the last one here. So this one is our first cube root with a fraction inside. Let's see if we can handle that. So we got to take the cube root of x to the 8th. So you're doing the same thing. You're splitting up the root top and bottom and doing them separately and simplifying. So 3 goes into 8. So we're dividing the root with the exponent that's inside. So 3 goes into 8 about twice, leaving 2 left over. Because 3 times 2 is 6. If I subtract it from 8, there's 2 left over. All right, so then this one here, I have to take the cube root of 8. And we've taken cube roots of 8 a few times now. But if you guys don't know, 8 breaks down into 3 2s. So that makes a triplet of 2s. So 2 comes out of the root because it's a cube root. And then 3 divides into 6 twice. So we have y squared that comes out of the root. And there's no roots in the denominator, so we're not worried. All right, so I think we've done some pretty clean problems. Let's get into the messier ones, like when we have a root in the denominator, like this one here. In part E, you can see there's a square root of 7 already in the denominator. And so what you have to do is get rid of it, and this is called rationalizing. So anytime you have a radical in the bottom and you have to get rid of it in the denominator, this is called rationalizing. And what you do is you multiply the square root, the same square root, on the top and the bottom. The reason why you do this is, I'll show you the first time, but I won't do it in the future. But square root of 7 times square root of 7, we learned in multiplication, for radicals, you would multiply the insides together as long as the roots are the same. So they're both square roots. 7 times 7 is the square root of 49. And then the top two square root of 7, just hop on over since they don't multiply the insides together. They're different. This is a coefficient and this is a root. But the square root of 49 is simply 7. And notice that when you multiply a root by its same root, it removes the square root, leaving whatever numbers inside. So now you don't have a radical, and you have rationalized the denominator. That is what we refer to rationalizing. The denominator is trying to get rid of the root from the denominator. All right, let's try f here. So same thing, this one has a square root of 3 in the denominator, so we're going to rationalize it by multiplying it by a square root of 6. So remember, that helps us cancel out the square root, leaving us the 6 that's now in the denominator. And now we have negative 18 and a square root of 16. Now don't leave your answer like this because you can definitely simplify the coefficients. This is a negative 18 and 6. What goes into 18 and 6? Probably a 6. 6 goes into 18 3 times and 6 goes into 6 1 time. So you can really write this as a negative 3 square root of 6. There's a 1 in the denominator, but I'm not going to put this over 1 because that's a little bit redundant, but you could. And there we go. So if you are catching on to E and F, let's try out G. G's a tricky one here. So this one, again, is a square root with a fraction inside. So let's do our splitting of the denominator and the numerator. So this ends up being, let's see, 2 goes into 5 twice, so G2 comes out. And then there's 1 G left over, so G to the first power is inside. This one, 2 goes into 3 1 time, so H to the first power comes out. But then I have 1 H left over, because 2 goes into 3 1 time, but there would be 1 left over, so square root of H is here. So if you have a square root of H in the denominator, you're going to need to rationalize by multiplying the top and bottom by that square root of H. So what this means is that H is just, a variable that, represents any type of number. So let's go ahead and multiply this. So I know that if I multiply these two H's together, they're going to cancel and just leave an H. So in this case, H times this h that comes out is going to give me 2 h's in the bottom, which I can always combine later. And then this g squared comes over h times g. They're both square roots, so they come together, and I can write this as g of h. So I just multiply these two since I'm multiplying, and I put them under one root. Now from here, I could probably combine these two. I'll just go down since I'm running out of room. Call this, I'm going to leave the top the same, and then h times h is just going to be h squared. And that's it. That's all I could do. Can't really cancel anything out in the top and the bottom since g and h don't cancel. So that's it. All right, let's get into dividing with conjugates. So we've talked about conjugates before when we were dealing with imaginary numbers. So just a refresher here. We use conjugates also when we're dividing with roots because they are helpful at canceling out roots in the denominator. So back then when we had imaginary numbers, let's say like 3 over I plus 1, we would use the conjugate I minus 1 and multiply. This would help eliminate the imaginary numbers that are in the denominator. So imaginary numbers, we don't like to divide by imaginary numbers. And it's because it's difficult to divide by. And roots, it work the same way. We don't like to divide by roots because they're difficult to divide by, so we try to get rid of it in the denominator first. And that's how we can try to simplify. So just as a refresher here, whenever you have, let's say, a root in the denominator, let's say that it looks like this. If you want the conjugate, then all you have to do is switch the sign that's in the middle. So if this you have a square root of 5 plus 7, then the conjugate would have to be the square root of 5 minus 7. These are going to be conjugates of each other. All right, so let's get into example 3 on how to divide radical expressions using conjugates. And let's make sure that we also simplify as we're going. So this is one of the situations where you have a root in the denominator, and maybe it's not as easy to remove because there's 2 terms in the denominator rather than what we were looking at. It was nice and clean. There's only 1 root in the denominator, so we just multiply it 1 time. So if you have 2 terms, then it's a little bit more complicated and you got to use conjugates. So I'm going to multiply the bottom by its conjugate first. So that's going to be square root of 3 plus square root of 2 on the top and bottom. And then from here, I'm going to need to FOIL this out. So however you do it, let me put this around parentheses to make this a little bit easier. So I'm going to multiply the 6 with the top. Basically, I'm going to multiply it across. So 6 times square root of 3 is going to be 6 square root of 3. 6 times 2, square root of 2, is going to be 6 square root of 2. So that's the top. Now I'm going to multiply the bottom and FOIL it out. So square root of 3 times square root of 3 is going to give me 3 because they're both under a square root, so the number that's inside comes out. So square root of 3 times 2 is going to give me, they're not the same, so I'll get a square root of 6. 3 times 2 gives me 6. Then I have to multiply the square root of 2. So negative square root of 2 times positive square root of 3 is negative square root of 6. And last but not least, negative times positive makes a negative. And then square root of 2 times square root of 2 is going to make it a positive 2 because the roots would cancel, leaving the same bases to come out. Now, what I start to notice is that these cancel because they are opposite signs of each other. This one's a positive, this is a negative, so they will cancel. The top here, I can't combine them because this one's a square root of 3 and this is a square root of 2. So I'll just have to bring them down as they are. But the bottom here, this is a 3 and this is a 2. So they're just numbers I can combine. 3 and 2 makes a 1. 3 minus 2 is 1. And so I have something over 1, so it's a little bit redundant to write it like this. So I'm just going to write it as 6 square root of 3, 6 square root of 2 as my final answer. And that's all I can do. So I want you to notice when you multiply by the conjugate radical that it eliminates the root that was in the denominator. Notice that I no longer have the root in the denominator, which is exactly what I want to do, so it makes the math a little bit easier. Now I could probably easily plug this in a calculator and get my number. All right, this here I am going to go ahead and take care of that root by multiplying by its conjugate. So again, I have a root in the bottom. There are two terms, so I'm going to multiply this by the square root, meant to write a square root of 2 minus 3. And notice that anything I'm multiplying to the bottom, I'm multiplying to the top. And there's a reason why we do this in mathematics is because when I multiply to the top and bottom, I'm not affecting or changing anything about the value of this. That's because if you take this over this, if you divide them, technically it's just 1. When you put two expressions that are identical on top of each other, it's still just 1. So if I were to go ahead and multiply this straight across, let's put that in parentheses. I always like to write it in parentheses so I know what I'm distributing. 5 times square root of 2 is square root 5 square root of 2. 5 times negative 3 is negative 15. And then I'm going to multiply the bottom. So square root of 2 times square root of 2 is a positive 2. Square root of 2 times negative 3 is negative 3 square root of 2. 3 times square root of 2 is positive 3 square root of 2. And then 3 times negative 3 is negative 9. So we can see that the middle terms cancel. And turns out when you're dealing with conjugates, the middle terms always end up canceling. That's how you know when you did it right. So we can see the top just comes down. We can't combine anything. So 5 square root of 2 minus 15. And then 2 minus 9 is going to give me negative 7. And then from here, I don't think I can reduce this. 5, 15, and 7 don't have anything in common. So I'll just keep the answer like this. I'm good. All right. Next part here is going to be part C, last one. So this one, I have a minus and a plus sign. So if I were to take care of this, let's go ahead and multiply by the conjugate. Since I already noticed there's two terms in the bottom, one of them has a radical or a root. So the conjugate would be square root of 3 minus 4, square root of 3 minus 4. So if I go ahead and multiply them, I'm going to need to FOIL the top and the bottom. All right, one by one here. So we have 6 times square root of 3. 6 times 4 is negative 24. Negative square root of 3 times positive square root of 3. So that's going to be a negative. Square root of 3 times square root of 3 is going to make this a 3. Okay, negative times negative makes a positive, and then square root of 3 times 4 is going to put the 4 in front and the square root to the side. All right, I'm done with the top. So now I'm going to multiply the bottom. So square root of 3 times square root of 3, again, is a 3. And square root of 3 times negative 4 is negative 4 square root of 3. Positive 4 times square root of 3 is going to make this positive 4 square root of 3. And 4 times negative 4 is going to give me negative 16. So the middle terms cancel like they always do. I can combine maybe these two together, and I can also combine these two together as well since they both have a square root. So let's take care of the square root first. So since both of them have a square root of 3, I'm going to take the 6 and add it with the 4 to get a 10. So that would make it 10 square root of 3. Then I'm going to take the 24 and subtract it with 3 to make negative 27. And then from here, I'm going to clean up the bottom. 3 minus 16 is going to give me negative 13. And 10, 27, and 13 don't have anything common to reduce. So I'll leave my answer like this. So that's it for this video. In the video down below, there are some practice problems you can definitely try out over the concepts we just worked on with dividing. So dividing and multiplying. So all of the concepts we've gone over, multiplying radicals and dividing radicals. If you guys need extra practice, there it is. And then for question 2, I just encourage you guys to start the project for part 2, where you list out equations that you would graph to make a picture. So remember, your part 2 is going to ask you to graph a square root, 2 square root functions, and 2 cube root functions. And you're going to graph them and try to make an image. You can also use extra functions like linear functions, absolute functions, and quadratics. But as you are practicing, feel free to use this part of the journal to help kind of brainstorm what equations you want to do for your part 2 of the project. But that's it, and let your teacher know if you have any questions. Bye, guys.